Sending messages into the past just got easier. Or, as the headlines put it, we figured out a new way to send messages into the past, and physicists say it's possible to send messages backward in time. Even more amazing, these headlines are based on a paper published in PRL, the top journal in the field. As you've guessed correctly, no one's yet figured out how to actually send messages into the past. This is a theoretical study, but it's quite interesting indeed. And no, it doesn't involve a DeLorean, a time ferry, or a black hole behind a bookshelf. It just requires a little bit of quantum physics. Let's have a look. Quantum physics has an uneasy relation with causality. This is because once you accept that particles can do multiple things at the same time and factor in that Einstein tells us there's no objective way to tell what happens at the same time, then quantum mechanics also tells you that generally you can't tell what happened in which order. Causality becomes as uncertain as the rest of quantum physics. And of course, the first question you might have is, can I make money with it? Who wouldn't want to tell their younger self to buy Nvidia stocks without having to grow a wormhole in the basement? The new paper is a continuation of an earlier work. It comes from an MIT group, and the scenario they look at is loosely speaking this. You have a receiver device that you've built at some time, and that's ready to receive messages from the future. Before you build the device, you can't get any messages. Then you have a special quantum state that you prepare and you let it do its quantum thing. And once the quantum state has done its thing, there's a sender who measures the quantum state, and that, so the idea, injects information in the message receiver in the past. In the new paper, they show that this still works if there is noise in this communication channel. Amazingly enough, if you want to send messages into the past, the noise is less of a problem than if you want to send it into the future. The authors finish their paper in style, referring to a 1985 paper co-authored by E.L. Brown and M. McFly. Okay, but leaving aside the noise, just what do they say we must do to send messages into the past? They're using what's called post-selection. This basically means that after you've done the measurement of the quantum state, you only look at specific outcomes. You see, in quantum physics, we can't normally predict the outcome of an experiment, but they postulate that we basically live in a universe with only one outcome. And then the message that you get sent into the past is the outcome which will happen. Okay, but wait, how is this not just making a prediction? Well, to me, this is the key point of the paper. In general, you can't tell these two things apart. Forget the quantum stuff for a moment. Imagine that you just sit there with your device that can receive messages from the future, or so you think. It has a screen and noise flickers on the screen most of the time, then suddenly it says, buy Nvidia. You go buy Nvidia and a year later you're rich. But did you get a message from the future, or is your machine just good at predicting the stock market? There's no way to tell these two things apart. I don't know about you, but if I had such a device, I wouldn't care. Physicists could discuss until the end of time whether it does really receive messages from the future or whether it's just crazy good at making predictions. I'll be sitting at the pool. Cheers. That said, in today's reality, we can't predict the outcome of a quantum measurement, and post-selection isn't something you can magically enforce on our universe. This means that for practical purposes, the device works more like this. Suppose I set up an ex-Twitter account and post 100,000 messages predicting the next major LA earthquake for any possible day until 2100. Then, once it happens, I delete all messages but one, celebrate the correct prediction, and claim that it was given to me by a time traveler. Works on X, doesn't work in reality. So I have to give this paper an 8 out of 10 on the bullshit meter. The maths works out, but their interpretation is highly questionable. That's the real story here isn't that physicists have invented a working telephone to yesterday. The story is that physicists are slowly rethinking temporal relations, which I think are much more complicated than the simple cause-effect idea that we're used to. And if they finally work out how to send messages into the past, I promise I'll have a word with my past self about questionable hairstyle choices. This summer might get very hot. In the past month, we've seen a lot of headlines about the long-term weather forecasts that are suggesting it's not going to be nice. We're heading into a super El-Niño with a 100% chance, the headlines say. It's not just an inconvenience that'll drive up your electricity bill, it might cause widespread famine in Africa and more wildfires. What's going on and how much do we actually know? I have a brief summary. Global average temperatures have been rising with the carbon dioxide content of our atmosphere, but it's not a steady increase. The temperature has a lot of fluctuations from year to year. There are many factors which contribute to this: volcano eruptions, wildfires, and land use changes in solar radiation and cloud cover, and so on. But one of the most relevant contributions to the fluctuations is the El-Niño Southern Oscillation, ENSO for short. ENSO is a fluctuation on the scale of several years, and it affects how much heat is stored in the oceans. Sometimes the oceans contain a lot of heat and less in the atmosphere, and sometimes it's the other way around. The oceans give off heat, and that gives some extra warming to the atmosphere. In such years when the ocean gives off heat, the average global temperatures spark particularly high. El-Niño is the warmest of the ENSO phases, and it typically lasts 9 to 12 months. This is why El-Niño is one of the most relevant factors for long-range weather forecasts. It doesn't just affect the average temperature, it also affects rainfall patterns, and with that, phases of drought, heat waves, fires, and extreme events across big parts of the world. The world's meteorological organizations keep close track of the patterns that tell them when the ENSO is changing by measuring things like ocean temperatures, especially in the Pacific, and wind speeds. The news is now that the forecasts predict that we're likely to soon switch into an El Niño phase. These forecasts come from places like the US American National Oceanic and Atmospheric Administration, NOAA, the World Meteorological Organization, and the ECMWF, that's the European Centre for Medium-Range Weather Forecasts. Range! I meant range! They all agree that there is a high chance, NOAA puts it at 82% chance, that El Niño will begin sometime between May and July 2026, and then a more than 90% chance of it continuing through December 2026 to February 2027. The extra warming from El Niño will go on top of the global warming that we've already seen. And the thing is that the El Niño phases are not always equally strong. If they are particularly strong, the extra warming is particularly high, and the world's best forecasts now give a high chance that El Niño will be particularly strong this year, which has also been called a super El Niño. Just how high the risk is of that happening depends somewhat on the model. Earlier this month, the ECMWF did an ensemble forecast. This means they run the model multiple times with initial data that are within the uncertainty range. They found that now 100% of their model runs predict a super El Niño. The temperature normally on the y-axis here is not the global surface temperature, but the surface temperature in a part of the Pacific Ocean that's particularly predictive for El Niño. This recent ECMWF forecast is the main reason for the headlines, but NOAA too puts the probability at roughly 2/3 that it's going to be a strong or very strong El Niño, and the Australian Bureau of Meteorology says somewhat vaguely that their models suggest an event that'll likely be at least moderate in strength with the possibility of a strong event. This makes some people nervous because of the super El Niño, which lasted from 1876 to 1878. It brought an era of global drought and famine which affected India, China, Brazil, Southern Africa, North Africa, and parts of North America. An estimated 30 to 60 60 million people died, which at the time was about 2 to 4% of the entire world population. And today, we're in a situation where many countries, especially in Africa, are already close to famine. Now, it must be added that the 1876 Super El-Niño catastrophe was not just caused by the climate conditions, it was also caused by colonial policy affecting food availability, inefficient agriculture, and lack of global support systems. Then again, today we have aggravating factors too, such as the war in Iran that's causing supply chain problems with fertilizer, and more generally that no one really cares how many people die in Africa. Somewhat closer to home, the El Niño events actually don't affect the weather in Europe all that much, because our next door ocean is the Atlantic, not the Pacific. It does, however, affect the US West Coast, where it's likely to be a nasty season. Sorry, California. In any case, my summaries of the headlines are mostly right. The world isn't going to end, but it'll be a difficult summer for big parts of Africa, Southern Asia and Australia, and the US is likely to suffer through more heat waves. So the good news is the models mostly agree. The bad news is they agree in the way doctors agree when they mumble interesting case. Thanks for watching. See you tomorrow.